Hello class 8C. In our last class we discussed about law of conservation of mass. Once again, just to revise the thing. According to the law of conservation of mass, it states that matter is neither created nor destroyed during a chemical reaction. That means there is no change in mass during a chemical reaction. For example, if you have got 10 grams of water, if you boil it to form steam, it will form the same amount of steam, that is 10 gram. And if you cool it also to convert into solid form, it will form the same amount, that is 10 gram. This we call the conservation of mass. In other words, we also define the law of conservation of mass as the mass of the products equals the mass of the reactants in a chemical reaction. So this we have seen in our previous classes. So for example, when magnesium bonds in oxygen, it will form magnesium oxide. If you take the weight of the magnesium and oxygen combined together before the reaction, and if you measure the weight of the product that is formed after the reaction, it will remain the same. Okay. Now today we'll see the activity which verifies the law of conservation of mass. In this, what we have done is we have taken what are the materials that is required is a conical flask. This we call it conical flask with cork. This one stopper we call it cork. A measuring cylinder, it is a apparatus which is used to measure the volume of the liquid. A test tube, this test tube. A weighing balance string, this tried string. Barium chloride solution and sodium sulfate solution. These are the two solutions that you need to take, or the reagents. Okay, now what you need to do is procedure: take 10 ml of sodium sulfate solution in a conical flask. So in this conical flask you take 10 ml of sodium sulfate solution. Okay, after that take 10 ml of barium chloride solution in a test tube. So in this test tube, first let it be out, and to this you add 10 ml of barium chloride solution. So one solution is in the conical flask and other is in the test tube. Okay, so in the conical flask we have got sodium sulfate solution, and in test tube we have got barium chloride solution. Now tie the test tube using a piece of string and suspend the test tube in the conical flask carefully so that the solutions do not mix with each other. So what you need to do is you need to tie the test tube and put it in the conical flask in such a way so that the content of this does not fall over here. Okay, and it should be cork, that means so that the solutions should not come out. So close the mouth of the flask with a cork so that the string holding the test tube is held firmly. Carefully weigh the conical flask with its content on weighing balance and record the reading. So after this arrangement, you take the weight of this substance, you take the weight of this, okay, and note down the reading. After that, now tilt the test tube so that the okay, now after that what you need to do is, after weighing it, you just tilt it or you just shake it. So what will happen, the content which are present in the test tube will go into this barium chloride solution and the reaction will take place. Okay, so now till the test tube so that the barium chloride solution mixes with the sodium sulfate solution, let the reaction takes place. So reaction will take place, and the reaction will take place in this way: barium chloride reacts with sodium sulfate to form barium sulfate, which is a white precipitate. It is a white precipitate plus sodium chloride. So you can see the both the solutions will be colorless before mixing, but when you mix it, the whole solution becomes white precipitate. Now after the white precipitate settles down at the bottom of the flux, weigh the conical flask again. So the reaction has taken place. Now you take the weight of this. Compare the masses of the conical flask before and after the chemical reactions. So after the reaction also you take the weight and just see the mass which we have taken before the reaction. You'll observe that it is observed that mass of the conical flask along with its content remains unchanged after the chemical reaction. So you'll observe that there is no change in mass. Whatever mass you have taken before the reaction, it remains same after the reaction as well. This experiment, so conclusion we can draw is, the experiment proves that there is no change in the mass during chemical reaction. Thus, the activity verifies the law of conservation of mass. Since there is no change in mass, we can verify the law of conservation of mass holds here. Okay. Now we have completed our chapter. Once again, just to make you remember whatever you have studied in this chapter, first we discuss about kinetic molecular theory, where we studied the theory that enables us to understand the behavior of molecules, solid, liquid, and gases. It's called the kinetic molecular theory. Then we also came to know about kinetic energy. The kinetic energy is the energy which is possessed by the virtue of the by the motion of the molecules. The kinetic energy of molecules of matter varies with temperature. The empty spaces between the different molecules of a substance are called intermolecular spaces, and the force of attraction between the molecules of a substance is called intermolecular force of attraction. A change in the state of matter depends on three things, as we know: the intermolecular space, the intermolecular force of attraction, and the collisions between molecules. Next, the intermolecular force is the strongest in solid. In liquids, it is not as strong as that in solid, and it is the weakest in gases. And lastly, we discuss about the law of conservation of mass, which states that matter is neither created nor destroyed during a chemical reaction. That means there is no change in mass during a chemical reaction. So these are the topics that we have studied in this chapter. Now, assignment for today, assignment number 5. Question number 1: as magnesium burns in oxygen to produce magnesium oxide, there is no change in mass. Explain it. And question number 2: how will you verify the law of conservation of mass with the help of an activity? The activity just now we have seen. You need to explain it in a brief. Okay, giving all the stating all the regions, procedures, and conclusions. Thank you.